In this video, we are going to look at capacitor banks and how health index is applied to this asset. So let us first look at the modes of degradation for this asset. Now, the presence of extreme climatic conditions may contribute to the premature degradation of pole-mounted capacitor banks. UV radiation, frequent wet and dry cycles, wind, and pollutants such as salt spray may all contribute to the degeneration of pole-mounted capacitor banks. Now, the structural integrity of the pole on which capacitor bank installed is also critical to the unit's proper operation. However, they are individually assessed as poles from which I talked about in a previous video. The service life of capacitors is estimated to be around 20 years. Capacitors, on the other hand, might fail prematurely owing to external events such as harmonics or overvoltage circumstances. Because capacitors are intended for specific currents and voltages, they do not provide effective voltage protection. Heating within capacitors can occur at the above-mentioned rated currents or voltages. The capacitor's internal problem might potentially cause it to heat up also. The heat inside the capacitor has the potential to inflict internal damage by melting internal components or causing a fire. The capacitor bank must work in accordance with the product's specifications as outlined by the manufacturer. For example, the voltage must be within the permitted range. Failure to do so accelerates the rate of capacitor bank degradation, which finally would lead to early end of life. Visual inspections are possible on a majority of capacitor bank components. Capacitor cans, external fuses, support insulators, mounting reel structures, concrete foundations, and connection hardware can all be visually inspected for defects or flaws. A bulged tank or blown fuses, broken bushing, leaking welds or gaskets, and visual examinations are all signs of common problems in capacitor banks, including complete failure. And in the case of support insulators, visual inspections can reveal damaged, cracked, or chipped insulators. Visual inspections can also reveal rusting of steel structures or concrete spalling in the case of structural foundations. Internally fused capacitor banks may be provided with alarms for different stages of blown fuses, which provide vital information about the failing elements within capacitor banks. Thermographic surveys, or what we call an IR test or infrared scans, have become one of the most efficient and cost-effective ways to locate hotspots around power equipment, such as the capacitor banks. And any hotspots in the bank can be detected using these IR tests. So let us now look at the different categories that compose the health index for the cap banks. Let us start with age. Now, there are only 3 ratings in this category, and they are just 4, 2, and 0. So for a rating of 4, it means the cap bank has an age between 0 to 10 years of age. For a rating of 2, it means the capacitor bank is between 11 to 19 years. And lastly, we will assign the capacitor banks that are over 20 years a rating of 0. The second category is condition of the capacitor units. Now, for a rating of 4, it means that there are no indication of any capacitor failures through the bulging of cans or oil leaks, and there are no external sign of deterioration of gaskets, weld seams on cans, and no external corrosion or rust on cans also. Now, for a rating of 3, it means that there are fewer than 1% of capacitor cans indicate failure through bulged tanks or oil leaks, and there are minor external signs of deterioration of gaskets, weld seams, and minor rust on remaining healthy capacitor cans. For a rating of 2, it means that it is between 1% to 3% of capacitor cans indicate failure through bulged tanks or leaking oil. And there are significant external signs of deterioration of gaskets, weld seams, and a rusting of remaining unhealthy capacitor cans. Minor signs of oil leaks or oil stains on capacitor cans are also detected as well, and in this case, it should require some corrective maintenance within the next several months. As for a rating of 1, it means that there are more than 3% and up to 5% of the capacitor cans indicate failure through bulging of tanks or oil leaks, and there are major external signs of deterioration of gaskets, weld seams on cans, and there are signs of significant oil leaks or oil stains on healthy cans. and there are extensive external corrosion on rust on cans that can be found, and in this case it requires corrective action within the next several weeks. And lastly, for a rating of 0, that means that more than 5% of the capacitor cans indicate failure through the tanks being bulged and the oil leaks being detected. And in this case, the banks are unable to provide the intended function as it has been degraded beyond repair. The third category is condition of insulators. So for a rating of 4, it means that the support insulators, either rack or interact, are not damaged and are free of contaminations, chips or cracks. There are no presence of flashover burns, copper splash or copper wash, and the cementing and fastener seems secure. So in this case, a rating of 4 means good condition. For a rating of 3, it means that the rack is not damaged. However, there are minor contamination, chips, and cracks visible. The cementing and the fasteners are still secure. For a rating of 2, it means that the support insulators are not damaged. However, though, there are major contamination, chips, and cracks are visible, as well as there are some signs of flashover burns, and there are some signs of copper splash as well, but the cementing and the fasteners are still secure. For a rating of 1, the support insulators are actually damaged, or that the cementing and fasteners are not secure. As for a rating of 0, it means the support insulators or the cementing and fasteners are damaged beyond repair. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. The fourth category is infrared testing or IR results, and it only has 3 ratings like almost other equipment that I've talked before, which has 4, 2, and 0. So for a rating of 4, it means no hotspots detected, everything is good. For a rating of 2, it means that there are noticeable hotspots, but they do not jeopardize operations in general. As for a rating of 0, it means that there are various hotspots and it does or it may affect operations. Now, the last category is called overall condition of the bank. And in this case, we're just looking at overall how the bank looks, how the primary and secondary conditions look, any signs of abnormality, etc. So for a rating of 4, it means that the cap bank is externally clean and it doesn't seem like there's any signs of corrosion. All of the primary and secondary connections are also good. There are no signs of overheating or any other signs of abnormalities detected, etc. and the cap bank seems to be well maintained. So everything is good to go. For a rating of 3, it means that there are normal signs of wear with respect to the cap bank, but it doesn't seem like there's any red flags. For a rating of 2, though, there are 1 or 2 of the characteristics like the cleanliness of the bank, any signs of corrosion, connections, and signs of overheating. 1 or 2 of these are deemed unacceptable. And for a rating of 1, it means that more than 2 of the characteristics are unacceptable. And for a rating of 0, it means that the cap bank is defective and or damaged beyond repair. So now let us look at the weights in the health index. So the capacitor units condition is going to be the highest. So we would put the weight as 5, and then we would actually put the overall condition of the bank second highest. So we would actually assign a weight of 4 in this case. IR scan results are also important, but not as important as looking at the condition of the bank and its units. So we assign it to a weight of 3. Service life and the condition of insulators, not as important, so we would assign a weight of 2 for these 2 categories. So now let us go over an example. Consider a capacitor bank of 15 years, of which it will be given a rating of 2, with perfect condition units upon visual inspection, which is a rating of 4, which means that there are no bulging, leakage, or rust, with only chips, minor chips visible on the insulators, so a rating of 3, and that there are very minor hotspots detected, but they again are very, very minor. So it's so minor that we will just going to be given a 4 to it. And overall, the bank seems to be well maintained with normal signs of wear and tear. So we will assign a rating of a 3 to it. Now, you might fight for that. The minor hotspots might be given a 2 rating, but the thing is that this is not there's really no threshold. It's actually to the comfort of the guy who's giving the rating to. So for example, if the hotspots are so minor that you don't actually consider a problem, sometimes you might just want to assign it to a 4. I'm demonstrating this in this example just because that nothing is actually set in stone. Like it's not like it's a Bible where you need to follow it to a T. But it's more or less like, okay, well, it's to your comfort, or to the person's comfort in recording these conditions being assessed. So after all of this, let us calculate the health index for this unit. So now we are first going to, of course, calculate the score, with which we're just going to multiply the rating that we assessed by the weight, and we sum it all together, so it equals to 54. And then we would calculate the maximum achievable score. So the highest score is 4 multiplied by the sum of weights. So in this case, it equals to 64. Health index is the score calculated divided by maximum score multiplied by 100. So 54 divided by 64 times 100 equals to 84. And as mentioned in the fundamentals section, a value between 70 to 85 is considered good, and as such there might be deterioration of some components, and only normal maintenance are needed in this case. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.